Student, now we are going to solve that exercise 6.4 class 10 general maths question number 5. As you can see in the video, DEF are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratio of the area of triangle DEF and triangle ABC. So let's have a look, student, how to solve this one. Question number 5, exercise 6.4 class 10 general maths. Student, this is diagram of question number 5 as you can see in the video, and triangle ABC and DEF is the midpoint of AB, BC and CA respectively. Now look, student, after joining the midpoints, we have got one more triangle DEF. We have to find the ratio of triangle DEF and triangle ABC. Now look how to solve this one. First of all, in triangle ABC, D and F are the midpoints of AB and AC respectively. AB and AC respectively. Therefore, student, we can say that if D and F are the midpoints of AB and AC respectively, then DF parallel to BC, and this is by the help of midpoint theorem. Now student, look here, so I can write down here that DF parallel to BC, The reason is, actually I am writing the reason here. The midpoint theorem, students, you may be learned in class 9, midpoint theorem in the chapter of quadrilateral in class 9 geometry portion. Midpoint theorem, the line segment, the reason is the line segment joining the midpoints of two sides of a triangle is parallel to the third side, which means, student, D and F is the midpoint of AB and AC, and if we join these two, DF, this is parallel to the third side, means BC. This is the midpoint theorem. Student, now look here, DF parallel to BC, so here we can write here also implies DF parallel to BE, DF parallel to BE, we can also write here. Now look, similarly, students, we can say that here that EF parallel to BD, because E and F is the midpoint of the side BC and AC, and if we apply here the midpoint theorem, then EF parallel to BD, because if we take BC and AC as the sides of a triangle and E and F, if we join the midpoints, then third side would be AB. Like here also, AB and AC, D and F we join, and BC is the third side. So students, here DF is equal to BE, and similarly we can write here that similarly EF, similarly parallel EF parallel BD, and this is also by the help of midpoint theorem, same reason. Now look student, after that, so if DF parallel to B and EF parallel to BD, so we can say that student that BEFD is a parallelogram. So we'll write down here, therefore BEFD is a parallelogram. Now look after that, if it is a parallelogram, then we know that opposite angles of the parallelograms are equal. So if we take angle B equal to angle F, because these two opposite angle of a parallelogram here, so we'll write down that if we take angle B and this angle B and angle F, these two are the opposite sides of a parallelogram. Similarly here also D and E are the opposite sides of a parallelogram, and in case of BEFD, D is the diagonal, so if we join these two, then BF will be the diagonal. Now look after the student here, so we'll write down here that implies angle B equal to angle F. Angle F means angle B equal to angle F. Angle F means DFE or FED, whatever, EFD, because these two are the opposite angle of a parallelogram. And one more thing also students, here EF equal to BD, we can write down here now. So we'll write down here that EF equal to BD and BD equal to half AB. Why? Look, why this is, because there is a reason behind it. Now look, what is the reason here? EF parallel to DE, here EF parallel to BD and EF equal to BD. I have, look here now, I have written here EF equal to BD and also written BD equal to half AB, which means BD equal to half AB. This is also the theorem of class 9 from the chapter quadrilateral, the midpoint theorem. So what is the actual theorem? I am now writing down here. Look here now. Student, I am writing here the reason. Now look, what is the reason behind it? You have learned one theorem in class 9 that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. That theorem I am using here now. The line segment joining the midpoints line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. So this is the reason for writing this line here. Now look again student, what I've written here, you just match with the diagram. Now look once again. Look, EF parallel to BD and EF equal to BD equal to half AB, which means BD is the part of AB obviously and BD is half AB. Now look, now match with the theorem which I have written here. line segment joining the midpoints of any two sides of a triangle is parallel and the third is parallel to the third side and half of it. This is the theorem which I have used here now. So students, if it is do so, EF equal to BD equal to half AB, so we can say that here directly after that, and DF equal to BE equal to half BC. Now look here again, there is DF equal to B and DF parallel BC. So students, here DF equal to B and here if I write down DF equal to B or DF parallel B, here will be easier. DF parallel B, DF parallel BC and DF parallel BE here. Now look, if DF parallel B, so here we can write down DF equal to B and half BC. Now look into the diagram again. DF parallel to BE and DF equal to B and half BC. So using the same theorem here, line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. Class 9 theorem. So students, depending on the BEFD is a parallelogram, depending on this one we have got these 2 points. Now in the next part, this is all about the parallelogram of BEFD. Now look student, if I take ECFD, this parallelogram ECFD, here also student, if it is a parallelogram, then angle C and angle D are equal because opposite sides of parallelogram. I repeat again, ECFD is also a parallelogram, and in the parallelogram opposite angles are equal, so C equal to D equal. Now look, after that, here I am writing also ECFD is a parallelogram, therefore students, we can say that angle EDF equal to angle C, or simply I can write angle D equal to angle C. EDF here, look here now students, EDF equal to angle C I have written, or if I directly write angle D equal to angle C also okay, because these two are the opposite angle of the parallelogram and we know that opposite angle of parallelograms are equal. So here also I can write the reason. Opposite dot means opposite angle of LLGM means parallelogram, short from. Same here also I can write here opposite angle of parallelogram. Now look after that. Now student, triangle DEF, this triangle, and triangle CAB, these two triangle. I repeat again, triangle DEF means this small triangle and CAB means this big triangle. We have to prove that these two triangles are similar, but how to prove? Look here now. First of all, I will write down here now, in triangle. Now in triangle DEF and triangle CAB, here if I write down here that angle EFD, look here now, EFD equal to angle B. Okay, now look here, I am just writing here EFD equal to angle B I am writing, and here EDF equal to angle C I am writing here. Now look, where from this has come here, EFD. Look here students, here in the parallelogram BEFD I have written B equal to F. Now look, in the parallelogram BEFD, B equal to F I have written, and look here, this F is also the part of EFD. I repeat again, in the parallelogram BEFD I have written B equal to F, opposite angles of the parallelogram. So EFD Also the part of f here means common. That's why here I am taking this one as our equation number 1 and this one as our equation number 2. So we'll write down here from 1 and here I'm write down from 2. Now look student, two angles already we have prove here that the two regions already shown here. So for the similarity we can write down here that therefore triangle DEF similar triangle CAB and reason is angle criteria. Angle criteria. Now look after that. Now we can apply the area of the triangles, which means the 6.6 theorem. So we can now write down here area triangle DEF by area triangle CAB. Now look after that. So here students will write down that DF square by BC square and the reason is actually the 6.6 theorem and we'll write down the theorem now. Now write down here that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. This is the reason for this line, which means 6.6 theorem. Look student, one more thing, triangle ABC and triangle CAB are the same part of the triangle. CAB and ABC are the same triangle actually. So student, here in place of here that area triangle DFE, in place of this I can write here area triangle ABC also, because these two are same triangle. So this side will be equal DF square equal to BC square, and reason I am writing here that by the side, since triangle ABC equal triangle CAB. Now look after that student, DF equal to half BC. So we'll apply here now. We'll apply here this part, that DF, in place of DF I will write down here half BC. So let's have a look how to solve this one. Now student, here therefore area triangle DEF by area triangle ABC, and there is DF equal to half BC, so we'll write down here half BC, and there is DF square, so half BC square, and there will be BC square. Reason, since DF equal to half BC. Now look after that student. Now half means what? 1 by 4 BC square, and there is BC square. Cancel these two, and 1 by 4. So the last line will be here that area, therefore area triangle DEF, area triangle ABC equal to 1 by 4, and this is the answer of the question number 5, exercise 6.4. We have to find out the ratio. So this is a ratio, or the last line will be like this, or area triangle DEF is to area triangle ABC, this equal to 1:4. This is the answer of the question number 5, exercise 6.4, class 10 general maths.